Okay, let's try working on number 11 on these problems here. Number 11 is about the car and there's people riding in it and it goes over a pothole and it starts to oscillate. And so we want to use the mass of the car and the people in it and the period of oscillation to find the spring constant in there. Okay, well it says it's a 1275 kilogram car. And there are 153 kilograms worth of people in that car. So let's add that up. Let's see, we get 8 and then a 2 and a 4. Okay, so that's 1,428 kilograms. There's 4 springs on this car. So let's just assume that all 4 springs are equally taking a part of this. So we'll just take 1,428 and we'll divide it by 4. So to find the mass on each particular spring. So 1,428 divided by 4 is 357 kilograms. So each spring is going to take 357 kilograms. All right. Well, it's given us the period. It's telling us that the period is 0.84 seconds. And we want to find the spring constant. So remember, when we're talking about the period for a mass on a spring, it's period T equals 2 pi square root of m over k, mass over spring constant. Okay, all right. So let's start putting some numbers in. 0.84 seconds equals 2 pi square root of 357 kilograms divided by k. Okay, well now there's a couple of different ways that we can solve this. You could square each side, or you could let's divide by 2 pi on both sides. So we'll divide both sides by 2 pi. That'll get rid of that 2 pi right there. And then let's square both sides. So I square that, and that'll get rid of my square root sign here. Okay, and now I do this in my calculator, and I get 0.84 seconds divided by 2 pi, and don't forget the parentheses around the 2 pi if you're doing this with me at home. And let's see, and I square that, and I get 0.0179 equals 357 divided by k. All right, now all I do is I swap this and this. If I divide both sides by 0.0179 and multiply both sides by k, I can divide 357 divided by my answer for the previous one, and what I get is 20,000, there it is, 20,000 newtons per meter for the spring constant for the K for each of those.